All right, so we decided that we were going to have a look at, can machine learning replace viewers in subjective video tests? Because we know how much you all love doing subjective video tests. We normally do ITU or BT500 testing, which we know is a very accurate method. It's well understood. How you discard viewers is well understood because it's written in the paper how to do it. We know what the outputs mean, but it is expensive in time and effort, and it does need special rooms and lighting to be set up, which not everyone can afford to do all the time. Why we like doing BT500 at EBU PTS. The words that are used on the sliders actually have a cultural meaning, and across Europe, what those words mean changes. So in the UK, the difference between poor and bad's not very big, but in Germany, the difference between poor and bad is actually quite well spread out. So if you get a lot of people from across Europe to do your tests, you're meant to be able to get slightly better results. So
thank you. So we are speaking about VMAF, that is the Video Multi-Method Assessment Fusion, and that is a machine learning based algorithm from Netflix. It's an open source, and it uses a number of different basic quality metrics, and then it uses a regression to combine them, to blend them together, and it tries to predict the subjective test score. And the metrics are the visual information fidelity, the detail loss metric, and there is just one metric for the motion, that is just the difference between frames. And it is based on a training, so because of that we built a data set. This is just a schema. As you can see, the support vector regression combined together the feature extracted from a frame with the training on the subjective evaluation, and it produces a score that we interpret as a demos, a surrogate of the demos. Why we did that? Because the database from Netflix is quite different from a broadcaster database, because we have also up-converted content, non-cinematic camera, and so on, that Netflix doesn't have. And also we applied on HDR, so on high dynamic range content, and the question was, does it work also on different screen brightness? And also, so our bet was that a model trained on a broadcaster database could perform better than the model trained on the Netflix database. And also, why not, we could suggest to Netflix any further metrics that works better with HDR content. And this is our database, some of the videos that we used. In the database, there are videos from BT2000, that means 4K HDR. Then we have content from archive drama, from archive sports, with different resolutions. We use part of the videos of the database for the training and other videos from the database for the testing. And the subjective test, we had 15 videos with 3 resolutions from SD to 4K and encoded with 3 bit rates. The test methodology was the DSCQS, and the test environment was the BT500. The monitor that we used is the X300 from Sony, and we had 28 participants, thanks to all of them, and we had a 2 days test.
Okay, so this is what we've done over the last 2 days. We did a BT500 using RISE test sequence, and then put it into a VMAF machine learning training scenario. And then we used BBC test sequences, did a BT500 test on those, and also calculated the VMAF score based on the Netflix model and the model that we'd made over the one evening. So results using Netflix's HD model, they're actually quite well correlated, about 0.93. There's a couple of outliers. up here. The reason that those are outliers is one of the tests we did was we actually desaturated a couple of the videos to see if the Netflix model could spot that. All of the viewers spotted it and didn't like the fact it was desaturated. The Netflix model didn't spot that at all. Is it better than PSNR? So we've taken the PSNR scores of the videos we used, which have got a correlation of 0.65. So yes, it's better than PSNR for the tests that we did. We then trained a model using sort of 9 videos and 3 bit rates. Pearson correlation is 0.91-ish, so it's still better than PSNR, but it's not as good as the Netflix model. So conclusions, VMAF works only on luminance errors, and it works on a frame-by-frame basis, so if you put any motion errors in there, it doesn't really spot those either. There's a high correlation with BT500 when there's no chrominance error. The offset at the low end when using the Netflix model, that it didn't go through the origin at 0,0, suggests that the training data set doesn't cover types of error seen in archive video, low-cost video, live sport, etc., or doesn't have any sort of method of detecting those errors that you get in the older video. So to create a model of general European TV, we think we'd need lots of genres recorded over a large time period with different technologies, so that I could actually train a better model to notice the errors that we're seeing. So can machine learning replace viewers in subjective tests? We think only in limited circumstances. Certainly it has to be a single color space with no color space conversion, and it has to be a process which should not change the chrominance in any way. We don't think it can be used unsupervised at the moment, so an engineer is still going to have to watch the video to see if what the metrics telling him matches what he's seeing. But it could be used for something like tuning a specific codec instance. So if you've got some hardware that you need to tune, you could run off a couple of hundred videos and see what the VMAF score is on it, just to give you an indication of which ones you should investigate a bit closer. And that's it from us. So any questions?
Thank you.